This lecture is about verifying trigonometric identities. Really what it is getting you more practice with working with identities through a process of verifying an equation. One thing we would have done in previous section would have been to say, look at something like this. And I would have asked you to simplify this equation, simplify this expression, and you would essentially apply some trig identities, maybe some factoring, something like that, and you would have done your best to write it with as few trig functions as possible, and the answer you would have come up with would have been this answer. Now, the problem I know lots of students have when it comes to those types of questions is they don't know when they're done simplifying. Should I go another step further? Is there another identity I should use? You know, it's hard to do that. And what this section does is it kind of takes that idea of really simplifying an expression, but helps you in the fact that it's going to give you what the answer is you're looking for. Essentially what we're saying when we say verify the identity is you need to show that this equation here is always true. Well, the easiest way to do that is if I can somehow turn this side into this side, then it shows that it's always true, that one side always equals the other side. And previously we talked about how you can show that something's not an identity. And really what we're doing here is showing that this is an identity. And if it is an identity, it has to always be true. But really what this question boils down to is saying simplify this side into this side. So it's the same question as if I said simplify secant squared theta minus 1 over secant squared theta. You would simplify it, you would do whatever you got to do with it, and we'll see that in a second. And eventually, after you did some work, you would simplify it and find out that you simplify it into sine squared theta. But this question is actually probably easier than simplify, in that I'm saying simplify this, and here's the answer you're looking to get. So I know where I gotta go. It's just, how do I get there? What are all these in-between steps that I need to do to get from here to here? So in knowing the answer to a problem, it sometimes makes the problem easier to accomplish. If you're going to verify the identity, if you're going to do what I'm saying we have to do, simplify one side into the other side, what you should do is look to do a couple of things. So here's some strategies you should sort of go through. And these strategies are based off of some of the tricks we learned in the last lecture. So one thing you should do is really try and only work on one side of the equation. You know, pick a side of the equation based off of really which side is the most complicated. What I wouldn't do, what you can, but I wouldn't suggest you do, is start moving things from one side of the equation to the other side of the equation. That tends to make things more difficult than less difficult. I mean, it's not like you can't. It's an equation. You can do whatever you want. But I would not move back and forth across the equation in terms of I want to like take secant squared and multiply it over to this side. I wouldn't do that. I would say, okay, here's my equations, left side, here's the equations, right side. Let me leave it be and start working with it. Pick one of the sides to turn into the other side. And what you should do is take the complicated side first. I'm going to work with the most complicated side first, and I'm going to turn that into the simpler side. The reason being, if it's more complicated, there's more going on. If there's more going on, there's more you can do to it. Then, once you start to decide where you're going to want to start, you can do a couple of things. Think about factoring the expression. If there are fractions added or subtracted together, actually do that computation. You may want to square both sides of the equation to create some Pythagorean identity possibilities. You may want to somehow simplify so you don't have a fraction, or right, so that you have a single term in the denominator. And these are some of the tricks we looked at in the previous lessons. The next thing you want to start to do is look for the Pythagorean or fundamental identities, and that's where squares can come in. Well, how can you make the fundamental identities work, maybe if they don't work necessarily? If you don't see a square, how can you create a square? Well, you could create a square by squaring both sides of your equation. You could also do something we talked about, which is multiplying by conjugates. Multiplying by conjugates creates difference of two squares. Difference of two squares creates this fundamental or Pythagorean identity. So look for certain pairs that go together also. Sines and cosines work with the Pythagorean identity. Secant and tangents work with the Pythagorean identity. Cosecant and cotangent work with the Pythagorean identity. If you still are looking at it and say, I have no idea what to do, the least you can do is convert everything to sines and cosines. Because secant, tangent, cosecant, cotangent can all be written in terms of sine and cosine. So do that. But what you should do always is try something. Too many times these students look at something like this and go, I don't know where this is going to start. I have no idea how this is going to turn into this. And they give up. Pick something. There's always something you can try to do. Now, it might not be the right thing to do, but try something. You never know where it's going to lead. You may not see how this is going to turn into this right now. But if you try a step, that step could lead to one other step, and then that step can lead to another step, and another step, and another step, and maybe in the end, you get to where you're trying to go. But you may not have seen the path to get there necessarily, but by picking a particular path, it leads you down a road that takes you where you want to go. So let's do this example. So I want to verify that secant squared theta minus 1 over secant squared theta equals sine squared. To verify that, the easiest thing to do would be to turn this side into this side. So I'm going to start here. And I'm going to just say, what can I possibly do? And there's multiple ways to attack this problem. One thing I would say is, this should stick out to me. Secant squared minus 1. I should be thinking Pythagorean identities. But I have this identity that tan squared theta plus 1 equals secant squared theta. But that is the same thing as tangent squared theta equals secant squared theta minus 1. So I can use that. So then what I end up with is that secant squared theta minus 1 becomes tangent squared. That is over secant squared theta. Okay? I didn't get to where I need to be yet, so I'm still looking at this. What else could I do? Well, another thing I do is say tangent is sine over cosine. So tangent would be sine squared theta over cosine squared theta. So this is turning into that. But that's still over secant squared, but secant squared is 1 over cosine squared. Using my reciprocal identity. So I use my quotient identity to get to here. I use my reciprocal identity to get to here. I keep going. Well, I have a fraction divided by a fraction. I flip and multiply. I get sine squared theta over cosine squared theta times cosine squared theta over 1. The cosines canceled, and I got sine squared theta, which is what I was looking to get. So if this thing equals sine squared theta, and I was able to do that, what I really have in the end is that if this is equal to sine squared theta, and this side is sine squared theta, then it shows that no matter what theta is, I'm going to be doing the same thing to it on both sides. Therefore, this side should always equal that side, which proves it's an identity. Now this was a little sloppy. Alright, I'm going to show you how to write it down a little bit more concisely, but this is the basic idea of what we're trying to accomplish. Well, in that previous example, I could have done it different ways, and that's the nice thing about this. One person might see this problem one way, another person might see it another way, and and eventually you get to the same thing. It's like saying, okay, I want to get from point A to point B. One person might see I can get from here to here going this way. Another person might say I can get from here to here going this way. A third person might go straight between A and B. Either way, everyone ends up at B in the end. You took 3 different paths, but everyone gets to the final result. And that's a possibility for here. I mean, for these problems, it's not one way to do it all the time. Now, sometimes one way is easier than another, but it's not one way all the time. So let's look at this one. Verify the identity. What I would like to do is to turn one side into the other. So what I'm going to do is I'm going to say, let me turn this side into this side. Why did I do that? This seems like it's got a lot more going on in this right hand side of the equation, which means I feel like I can do more to it. Whereas the 2 secant squared beta, there's only so many things I'll be able to work with on that side to change it into something else. So what can I do? Well, you have 2 fractions added together. First thing that should come to your mind is, let me add these 2 fractions together. So if I was to add these 2 fractions together, I would have to find a common denominator. The common denominator, well, let's do it this way. I'll slow it down for you a little bit. The common denominator would be 1 minus sine beta times 1 plus sine beta. Would be the 2 denominators multiplied together. Well, if I have 1 over 1 minus sine beta, and I have to get this denominator, well, then I'm missing a 1 plus sine beta. So I do the same thing in the top. Same thing goes with this other one. I get 1 plus sine beta. I'm trying to squeeze this in here, I'm sorry. I'm missing the 1 minus sine over the 1 minus sine beta. So what do I get? Denominators are the same. I add the numerators. So this is going to be 1 times 1 plus sine, so 1 plus sine beta. This is going to be 1 times 1 minus sine, so 1 minus sine beta. Let me erase that. And this is what I'm working with. So what do I get? I get 1 and 1 is 2. I have sine beta and a minus sine beta cancel. So that's my numerator, 2. The denominator is 1 minus sine beta times 1 plus sine beta. But if you look, those are the conjugates of one another. If I multiply them together, I get 1 squared minus sine squared beta. Remember, I'm constantly working towards this, and I'm not there yet. But what else can I do? Look at it and say, is there anything else I can do? Well, this is really 1 minus sine squared, and I should start thinking Pythagorean. 1 minus sine squared is equal to cosine squared beta. One more step, cosine squared is reciprocal of secant, so then 1 over cosine squared, or 2 over cosine squared is equal to 2 times secant squared. So now I got what I was looking for. I was able to turn this into this. Review, what did we do? Here we just found the common denominator and added it together. When I combine my numerator, I get 2. When I multiply my denominator together using difference of 2 squares, I get this. This allows me to use Pythagorean identity. I use the fact that cosine squared beta equals 1 minus sine squared beta. Then here, since cosine squared beta is equal to 1 over secant squared beta, I plug that in here, make the secant squared basically come to the numerator, the 2 stayed where it was, and I ended up with this. So that verifies the identity. Alright, here's another one. Again, there's no real general purpose behind this right now other than getting you more accustomed to working with identities. And it all goes back to kind of the simplifying concept of, if I have the option, what would I rather work with? This thing here or this thing here? Me, personally, this seems a lot easier, so I can do that. But what if you're not given this? What if you're saying, okay, here you go. Do whatever you got to do with this thing. In calculus, you might be saying, take the derivative of this. Take the integral of this. Something like that. These are operations in calculus. If you don't know anything about calculus, don't worry about it. But the idea is, you might be asked to work with this, and you go, all right, well, that's fairly complicated. I really don't want to deal with it. There's a lot going on there. But if you understand that this is equal to this, which you can't see right now, but this, then I would rather work with this. And we have to verify that those things are equal to one another. And that's kind of the purpose right now. And the other purpose is just to get you accustomed to working with these identities. Alright, so pick a side. I pick this side. Why? There's a lot more to work with than there is the other side. Next thing, what do you want to do? Well, I'm seeing squares. So the second I see these squares, I'm thinking Pythagorean identity. Pythagorean identity for tangent is tangent squared x plus 1 equals secant squared x. So that's that one. This one, cosine squared minus 1, that would be equal to negative sine squared x. Right, what I'm using is that tan squared x plus 1 equals secant squared x, and that cosine squared x plus sine squared x equals 1. These are the two identities that I'm working with here. Now this second identity is what I'm using, but not directly, in that I had to manipulate the equation to make it cosine squared minus 1 equals negative sine squared. Okay. I'm still not where I want to be. I want to turn it into negative tan squared. Well, secant squared is 1 over cosine squared times negative sine squared x. Take that, I have negative sine squared x over cosine squared x. Well, sine over cosine is tangent, so another identity I'm using is that sine x over cosine x equals tangent x. Well, I have the negative. Sine squared over cosine squared should get me tangent squared x, which is exactly where I wanted to go. So one side equals the other side. So these three identities are the three identities I worked with, and these three identities allowed me to verify this particular identity. Here's another one. Alright, now here's one where you go, alright, pick a side. I don't see one side that's extremely more difficult than the other side. So in this case, it doesn't matter. But what you can't do is just say, I don't know what to do, so I'm going to skip it. You need to try something. So pick a side. It doesn't matter. I'm just going to say, for the sake of doing it, I'm going to pick the... It doesn't matter, I'm going to go left. So I'm going to start over here, and I'm going to say, well, what can I do? There's not a whole lot, but what I can do is say, alright, tangent x is going to stay tangent x, but cotangent x is 1 over the tangent. Now I have two things added together. What I'm going to do is actually try and add them. Well, this is a fraction, so I got to get a common denominator. Tan x is my common, which means I have to multiply this thing by tangent, which gives me tangent squared plus 1. And now you're starting to see something happening. Right? You may not have seen where this was going to go originally, but then this should stick out to you. What are you going to do here? Pythagorean identity, that's secant squared x over tangent x. Okay? So we're still not quite there yet. What else can we do? Well, we could very well stop there. Okay? And then I can say, alright, well, let me start working on this side now. And I don't necessarily have to turn this side into this side. But what I have to do is make them both meet up somewhere. So this one I got to this point. I may want to start working on this side and getting certain steps, but if I eventually can turn this side into the same thing, then that verifies the identity also. If you don't like that, then we could just keep going with the left hand side. I mean, there's lots of ways to deal with this. What I'm going to do is this. I'm going to stay on the left hand side. I'm going to say, okay, secant squared x over tangent is sine x over cosine x. So then I'm going to say, alright, then this is secant squared x times flip and multiply cosine x over sine x. Then what I'm going to do is I'm going to say this, I need more room, so I'm going to write this here, is secant squared x times cosine x times 1 over the sine x. Okay. Then I'm going to say secant squared x times cosine is 1 over the secant x, and 1 over the sine is cosecant x. Well, this secant and one of these secants will cancel, so I end up with secant x cosecant x, which is exactly where I wanted to go. So that verifies the identity. You may have looked at this problem and said, I see a totally different way of doing it, and started over here. Perfectly fine. If you can somehow make both of them match up to be the same, you verified the identity. Here's another one. Verify this identity. Pick a side. Doesn't matter which side you pick. In this case, I'm going to pick the right hand side. The right hand side looks like something we have worked with before. I gave you a problem previously that said write this so it's not a fraction. And one thing we did was we talked about multiplying by the conjugate. So what I'm going to do is say, let me look on this side. There's not a whole lot I can do, but I'm seeing this 1 minus sine x, and if I multiply by 1 plus sine x, the conjugate, I can start to look at squares with the difference of two squares formula and use Pythagorean identity. So what do I get? I get cosine x times 1 plus sine x all over 1 minus sine squared. 1 minus sine squared is cosine squared. So this denominator is cosine squared. This cosine cancels with one of these cosines, and I get 1 plus sine x over cosine x. Okay. Then what I can do is split this apart into 1 over cosine x plus sine x over cosine x, and I get secant x plus tan x, which is exactly where I wanted to go. Okay? But all these little tricks we've talked about, when we have fractions, let's think about actually adding those fractions together if they're added or subtracted. If I have something like this, think about multiplying by the conjugate. If I have a fraction, let me try and split the numerator apart. All these little tricks we've learned along the way will come into play here and get you more practice with them. But this is another verify the identity. I very well could have started on the left-hand side. I didn't, necessarily pick that side, but you could have. With all these problems, when I'm looking at these, I may not see how I get from here to here right away. But I start working with them. I get to one step, that leads me to something else, which leads me to something else, and eventually it takes me down a path. Will that path lead me to where I want to go? Not necessarily. I might not have chosen the right way to do it. That's going to happen. You're going to look at this thing and say, okay, let me try this, that, the other, and you're going to go down a path. I'm at point A to point B, and I might start going down a path, and that path starts to lead me off in the wrong direction. Well, all it means is don't go down that path. Pick another one. So let me try another path. And I start going this way. And eventually it starts leading me back to where I want to go. And if that's the case, then alright, then that's the one I want. And I might not necessarily see how to get from A to B. But if you pick something, sometimes it takes you in the wrong direction. Sometimes it takes you where you want to go. And don't stop trying to make this problem work. If the problem says verify the identity, it will work out. You just need to use what you have available to you to make it work. Okay, last one. Verify this identity. First, choose a side. It doesn't matter. You may have to work on both sides. It doesn't matter. just for the sake of doing it, I'm going to choose the right side. So the right side, I'm going to say, all right, I can split that apart. That's a little trick that I know to do because I see this a couple of times now. At least I know I can go 1 over sine theta minus sine theta over sine theta. Okay, and then what do I get? 1 over sine is cosecant, and sine over sine is 1. Alright. Problem is, I don't see anything else I can do. So I'm kind of done on the right hand side. Alright, no big deal. Let me see, what else can I do? Let me go to the left hand side. Left hand side, the first thing that should stick out to you is the cotangent squared. Right away you know that cotangent squared plus 1 equals cosecant squared. Pythagorean identity. So what I'm going to do is I'm going to say that cotangent squared is equal to cosecant squared theta minus 1 over 1 plus cosecant theta. Alright. Now what? Well, this is a difference of two squares. When I multiply conjugates together, I get the difference of two squares formula. And we've done this. We've taken one piece, multiply it by the conjugate, and get the difference of two squares. But at the same time, you can start with the difference of two squares and factor it as conjugates. So what I'm going to do is use that here. This numerator, cosecant squared minus 1, can be written as cosecant theta minus 1 times cosecant theta plus 1 over 1 plus cosecant theta. Well, guess what? These are the same. They cancel. And I end up with cosecant theta minus 1 equals cosecant theta minus 1. This side equals this side. Now, I didn't turn this into this, but I was able to turn one side into the other so that they get the same thing on both sides. If I get the same thing on both sides, it's equal. It's always equal. Verifies the identity. It's going to take a lot of practice for you to get good at this, but it is really, really useful, and it will get easier. The more comfortable you are with the identities, the easier time you will have with this. Now, the only issue is, as you learn more identities, we only have a very basic set right now that we've looked at. There are a lot more identities you could work with. These problems could become harder just for the sake that there is more of a possibility for you to choose from to start the problem. And like I said, sort of point A to point B, if we have more identities, there's more paths I can choose from coming out of A. Not all of them are going to lead me to B. And that's going to be the difficult part, is you may choose this path, it doesn't lead you to B. You may choose this path, it doesn't lead you to B. And what happens, lots of students will give up at that point. But keep choosing different paths, keep trying different things till eventually you get where you want to go.